My name is Ollie, and this is my Java 2 final project presentation. So here are the tabs that I have open. Let's pull up this really quickly. So the program is called Exotic Moves, and it's a dealership website or application within JavaFX, or that's run with JavaFX, and it lets a customer browse cars. You can filter the inventory, enter your purchase information, and yeah, that's pretty much the gist. So I organized it using model view controller design pattern. The three main parts are here. So the application class, the FXML interface, and the controller. So we have the entry point here. It extends Java's FX application class, and the main method calls launch, which starts the JavaFX runtime. And then FX automatically calls the overridden start method. So inside start, the FXML loader loads the FXML file, and then the loaded interface becomes the root of a scene. And that scene is placed inside the primary stage. So the stage, as we know, represents the application window, and it sets the title, which again is Exotic Moves. And the minimum dimensions, which we have 960 width and 680 height. So I set the title and minimum dimensions before displaying it with stage.show. And this class is purposely small because it only has one responsibility, and that's to start the application. The user interface is in FXML, and the application is in the controller. So let's get into the interface here. So the interface is meant to define the visual structure of the application. The root layout is a border pane. The top section contains the dealership heading. And the center contains a stack pane. And the stack pane holds 4 different VBox screens. So we've got the inventory screen, the vehicle detail screen, the purchase screen, and the receipt screen. So instead of opening a separate window for each step, all 4 of the screens stay in the same stage. So the controller changes their visible and managed properties, so only one screen is displayed at one time. So setting visible to all right, so setting visible to false here in this VBox hides a screen. And setting managed to false removes it from layout calculations, and this prevents a hidden screen from occupying empty space. Um, the FXML controls use FX ID to connect them to fields in the controller. And buttons use on action attributes. So, like apply filters. And this calls controller methods. So we then get into the controller, and this class manages the application's behavior. So the fields marked with @fxml are injected by the FXML loader. So for example, vehicle grid refers to tile pane in the FXML file, while brand filter would refer to the brand combo box. After the FXML file has been loaded, FX automatically calls the controller's initialize method. So the method first loads the vehicle inventory, and it then builds the brand and color and filter options from the actual inventory data. And I use streams to retrieve each vehicle's brand or color. Um, the The distinct operation in my code removes duplicate values, while sorted puts the results in alphabetical order. The price and convertible filters use fixed categories. And um, the method selects default values and displays complete inventory. So then we get into vehicle model and inheritance. Here we are. So the abstract vehicle class here stores the information shared by every vehicle. So you can see brand through image path, and that's going to show the picture of the vehicle. The fields are private and final, which protects the vehicle data from being changed after construction. The class provides the getter methods and this allows the rest of the program to read the values without directly accessing the fields, which demonstrates encapsulation. Vehicle is abstract because the program should create a specific type of vehicle rather than a generic vehicle. And it declares abstract method get vehicle details to return a formatted description. So for inventory management, the inventory manager class owns the collection of vehicles. So the load inventory method clears the collection, adds each vehicle, and sorts the results by brand and model. So clearing the list first prevents duplicate vehicles if the method is called more than once. And it returns a list of, or the list copy of vehicles. And this gives other parts of the program a read-only copy instead of exposing the original mutable list. The logic is kept within the inventory manager, so it separates inventory responsibilities from screen management responsibilities. I think we should give it a whirl. So let's start it, see how it looks. Here we are. So the app initially displays the complete inventory, and these filter options are populated during the controller's initialization. So I can combine filters if I'd like. So let's say blue, Aston Martin. I can combine them because the inventory manager joins each predicate using AND. So this vehicle must satisfy every selected condition. And each card is created dynamically from a vehicle object. So we can see it's filtered. This is the only blue Aston Martin. And when I open the detail screen, the controller saves this vehicle as a selected vehicle. And that lets the purchase and receipt screens continue using the same object. So let's go through. Once the information is valid, the receipt class formats the transaction. So that wasn't valid. You see it gave us a specific reason why it didn't work. So it formats the transaction and masks the card number, so only the final 4 digits are shown there. And then returning home clears the customer's information and resets the vehicles and filters. So yeah, it's a work working application here. Thank you for watching.